Unit 2, Part A, Lesson 4, Combinations. Objective, to solve a simple equation or inequality in which it is necessary to make both zeros and ones.
Now that we have looked at the two types of basic open sentences, the next logical step is to consider what to do if both are combined in a single equation or inequality. For example, look at this equation. 3w plus 4 is equal to 10. Here we have 3 w's, we would rather have 1 w, and we have a 4 added on that we would rather not have at all. In other words, we need to make a 0 out of the 4 and make a 1 out of the 3. So what will we do to make a 0 out of the 4? Correct. We add negative 4. We note it in the margin. Do it to both sides, and we get 3w is equal to 6. Now, to make a 1 out of the 3, we think of 3 as a fraction, 3 over 1, and multiply both sides by its reciprocal, 1 over 3. We get 1w is equal to 2 for the solution statement. Checking by substitution, we verify that 2 is the solution. The solution set S is 2, and the graph of that set on a number line is obvious. Now you might ask why we made the 0 first. Could we, in fact, have made the 1 first? Let's see. Starting with our original equation, 3w plus 4 is equal to 10, we could multiply both sides by 1/3 to make a 1 out of the 3 first. We must be very careful here because we must multiply both sides. This will require the use of parentheses, especially on the left. Then we can apply the distributive property to actually perform the multiplication. We get 1w plus 4/3 is equal to 10/3. This is not very pleasant looking, but it certainly gave us 1w. So how can we make a 0 out of 4/3? Be careful. That's right. Add the opposite. And what is the opposite of 4/3? Yes, negative 4/3. Remember, we are trying to make a 0. And what do we get when we add negative 4/3 to both sides? On the left, we get 1w plus 0, or simply w. And on the right, 6/3 or 2. Exactly the same solution we arrived at before, requiring exactly the same number of steps. So it really doesn't matter which we do first, does it? Make a 0 or make a 1. However, based on this example, you might have a rather strong preference. Let's look at both methods together. What do you notice? Right. The second method involves significantly more fractions than the first method. Now, there is no method that will guarantee we will never work with fractions. But if we had made the 0 first, we would have eliminated a portion of the possibility. It's still your choice. All right. How about inequalities? Consider this example. Negative 6x minus 2 is greater than or equal to 40. Again, we have only to make a 0 out of the negative 2 and a 1 out of the negative 6, and we should have what we want, 1x. Adding positive 2 to both sides will make the 0. And multiplying both sides by negative 1/6 will make the 1. Uh-oh. What's that warning signal? It's reminding us of something. Remember? In a previous lesson, we discovered that multiplying an inequality by a negative number required us to reverse the relation symbol to maintain the integrity of the sentence. We must always be alert to that condition and never forget to compensate for it immediately. There, that's better. Okay, what do we end up with? One x is less than or equal to -7. Checking with a number such as -10, shows us we are probably correct. Now, realizing the difficulty in writing a solution set, we can show it on a number line. It starts at -7, includes -7, and also includes all numbers to the left of -7. Once more, we see that equations and inequalities are solved using the same procedures. You simply have to ask yourself whether you want to make a 0 or a 1, and be sure you operate on both sides.